Welcome to today's video on section 4.2, talking about trigonometric functions and the unit circle. So the unit circle is defined as a circle whose radius is 1 unit in length. So any circle with a radius of 1 unit is called a unit circle. So in this case here, if you notice, the radius here would be 1, here would be 1, here would be 1, here would be 1. So these points on the circle where the circle intersects the coordinate plane, this would be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Also, any radius drawn from the center to the edge here would also be 1. Now this helps us to define how to find the sine, cosine, tangent of any angle, because if I rotate an angle, if I rotate an angle this direction, call it theta, and let's say this angle, the terminal side intersects this point on the circle P, and P has an x and y coordinate, we could draw a right triangle here, and notice, let's say here, that this side here will be the same as the x value. This side here will be the same as the y value. So when you find the sine of theta, remember it's opposite over hypotenuse, so it's y over 1, which is 1. Cosine theta is adjacent over hypotenuse, so it's x over 1, which is x. Tangent theta is opposite over adjacent, so it's y over x. Then you have your reciprocal functions. Cosecant is 1 over y. Secant is 1 over x. And cotangent would be x over y. So if it's a unit circle, we can use the fact that the hypotenuse is always 1 to give us these ratios. The sine is y, cosine is x, tangent is y over x. So, using that, if t is positive, remember that if t is positive, that the angle is going to go this direction and intersect the point on the circle here. That's if t is positive. If t is negative, remember that t will go this way and intersect the point on the circle. So down here below, I gave you basically what I wrote on the first page, the definitions of the 6 trigonometric functions in terms of the unit circle. So let's see how we can do this. So if we give you that the angle intersects the point on the unit circle at rad 3 over 2 and 1/2, which is right here. And remember, with the quadrants, first quadrant, second quadrant, third quadrant, fourth quadrant, that x and y are both positive in the first, it's negative positive in the second, negative negative in the third, and positive negative in the fourth. So here we're trying to find the 6 trigonometric values. We'll call that angle theta. So sine theta is just the y coordinate, so it's 1/2. Cosine theta is the x coordinate, rad 3 over 2. Tangent theta is going to be 1/2 over rad 3 over 2, which equals 1/2 times 2 over rad 3, which equals 1 over rad 3, which is rad 3 over 3, because those cancel out. The cosecant is just the reciprocal of that, so it's 2. The secant is the reciprocal of the cosine, which is 2 over rad 3, which when you rationalize it, gives you 2 rad 3 over 3. And then the cotangent is the last one, and that's just the reciprocal of the tangent, so you can do rad 3 over 2 divided by 1/2, which is rad 3 over 2 times 2, which is rad 3. So there's your 6 trigonometric functions based on the point that they gave you, because here's the x and here's the y. Now to find the values of a quadrantal angle, remember a quadrantal angle is one that lies on the axis. You have to remember the first picture that we drew of the unit circle, where this was 1, 0, 0, 1 here, -1, 0, 0, -1. 3 pi over 2, remember, starts here and rotates to this y-axis here. So here's your x and here's your y. So sine 3 pi over 2 is equal to -1. Cosine 3 pi over 2 is equal to 0. Tangent 3 pi over 2 is y over x, which is -1 over 0, which is undefined. Cosecant 3 pi over 2 is equal to -1. Secant 3 pi over 2 is equal to 1 over 0, which is undefined. And cotangent 3 pi over 2 is equal to 0 over -1, which is 0. So that's how you would do it on a quadrantal angle. The domain and range of sine and cosine. The domain, you can find the sine and cosine for any angle. The range is always between -1 and 1. Because think about in a right triangle, the hypotenuse always has to be bigger than the opposite or adjacent, so that limits it to less than 1. And then on the unit circle, the biggest x value is going to be 1 and the smallest is -1. All right, trigonometric values of pi over 4. If you think of the picture, and remember this is 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi again. If it's at pi over 4, it's in the first quadrant here, right in the middle. So if when you draw your triangle here, this pi over 4 angle means that these two sides are the same because it's right in the middle. It means you're going to have equal sides. Also think about if from here to here is 90, then pi over 4 or half is 45, which means this is a 45, 45, 90. If this is 1, then that means that the point here, these values are going to be the same. So I'll label them both x. So that means you're going to have x squared plus x squared equals 1 squared, Pythagorean theorem. And then you have 2x squared equals 1, x squared equals 1/2. Take the square root and you get 1 over rad 2, which rationalizes to rad 2 over 2. So the point at that pi over 4 intersects the unit circle would be rad 2 over 2 and rad 2 over 2, because these are both the same. Which means when you find the sine of pi over 4, it's just rad 2 over 2, because that's the y. The cosine of pi over 4 is also rad 2 over 2, because that's the x. That means the tangent of pi over 4, which is y over x, is just 1, which means the cotangent is also 1. The sine of pi over 4 is 1 over rad 2 over 2, which when you flip it, you get 2 over rad 2, which when you rationalize it, is going to give you 2 rad 2 over 2, which is rad 2. The same with the secant. So these are the values that you would want to memorize for pi over 4 angle. Even and odd trig functions. Remember, an even function is when you put in a negative and you get out the same, and an odd is when you put in a negative and you get out the opposite. The cosine and secants are even functions, meaning when you put in a negative angle, let's say t, then you get out the same as if it was positive. And I'll give you an example. So for example, if you look at pi over 4, right, pi over 4 is here. All right, the cosine of pi over 4 is equal to rad 2 over 2. Well, the cosine of negative pi over 4, well, negative pi over 4 would be here. And since x is positive in both the first and fourth quadrant, it would also be negative. It would also be positive rad 2 over 2. So that means that the cosine of negative pi over 4 is the same as the cosine of pi over 4, which means it's an even function. And that would apply for secant. For sine and tangent, when you put in a negative value, you're going to get the opposite of what the positive would be. And that would be the same for cosecant. And then also for tangent and cotangent. So if you look at it like sine pi over 4 is equal to rad 2 over 2, but then sine negative pi over 4, when you go into the fourth quadrant here, the y values are negative. So that means it's negative rad 2 over 2. So that means that the sine of negative pi over 4 is the opposite of what sine of pi over 4 would be. So if I wanted to find the secant of negative pi over 4, I know, because secant is even, that it's the same as the secant of pi over 4. And the secant of pi over 4 is rad 2. So that's how I use the concept of even and odd to do negatives. Reciprocal identities. Reciprocal identities, for example, the sine of t is equal to the reciprocal of the cosecant, and vice versa. That's a reciprocal identity. The cosine of an angle is equal to the reciprocal of the secant, and vice versa. The secant is the reciprocal of the cosine. The tangent is the reciprocal of the cotangent, and vice versa. The cotangent of the angle is the reciprocal of the tangent. Those are reciprocal identities. Quotient identity, because tangent is equal to y over x, then that means the tangent of any angle is equal to, since y is the sine and x is the cosine, the tangent is equal to sine over cosine. And the cotangent is the reciprocal of that. It's cosine over sine. Pythagorean identities, since if you looked at the unit circle, right, if this is 1, and then we said the point was xy, So here it's y, and here it's x. So x squared plus y squared is equal to 1, doing the Pythagorean theorem. Since x is cosine and y is sine, we can say cosine squared plus sine squared is equal to 1. That's the main Pythagorean identity. By dividing these by x squared, notice this cancels out and gives you 1. So 1 plus y over x was tangent, so tangent squared, equals 1 over x squared, which is secant squared. That is another Pythagorean identity. If I did the same thing, but divided by y squared, I would get the cotangent squared plus 1 is equal to the cosecant squared. So those are the three Pythagorean identities because they come from the Pythagorean theorem. Using identities to solve these problems. So the sine is 2/3, the cosine is square root of 5 over 3. So to find the cosecant, it's going to be 1 over the sine, so it's going to be 3/2. The secant is 1 over the cosine, which is 3 over rad 5, which when rationalized gives you 3 rad 5 over 5. The tangent is equal to the sine over cosine, so it's 2/3 over rad 5 over 3, which is equal to 2/3 times 3 over rad 5, which is 2 over rad 5, which is 2 rad 5 over 5. The cotangent is cosine over sine, which is rad 5 over 3 times 3/2, which is rad 5 over 2. This one, if you're given that the sine is 3/5 and you want to find the cosine, you're going to use that sine squared plus cosine squared is equal to 1, which means you have 9/25 plus cosine squared is equal to 1. All right, so if you subtract 9/25 from 1, you get 16/25. And then you take the square root, you get plus or minus 4/5. But since it says that it's between 0 and pi over 2, that is in the first quadrant. So that means it's positive, which means it's 4/5. A periodic function is one. We'll get it back here. A periodic function is one when you add a number to a value, it'll give you the same thing. Like it just keeps repeating itself after a certain amount of time. Both sine and cosine are periodic because the periods are 2 pi. Because if you just add a full circle, 360 degrees, you get back to where you started from. Like for example, 40 degrees and 400 degrees are the same angle. For tangent and cotangent, the period is pi. So if I were to find sine of 9 pi over 4, that is the same as saying pi over 4 plus 2 pi plus 2 pi, which will just mean that you find the sine of pi over 4, which is rad 2 over 2. For tangent negative 5 pi over 4, remember that tangent is an odd function, which means that's going to be the opposite of tangent 5 pi over 4, which means that you're going to take the opposite of the tangent of pi over 4, and since the period is pi, 5 pi over 4 is pi over 4 plus pi, which means it's the opposite of tangent pi over 4. Since tangent pi over 4 is 1, it's -1. All right, that concludes our video for today, and I hope you enjoyed it. And if you have any questions, please ask. Have a good evening.